So yesterday we talked about how to use completing the square in order to solve quadratic equations. We're going to work on completing the square again today, but we're going to use it to rewrite equations in vertex form. So let's go ahead and get started with this problem. We have this equation, which is in standard form, ax squared plus bx plus c. We're going to rewrite this equation in vertex form by completing the square. So it's a little bit using the same process as yesterday, same philosophy, but in a little bit different way. And so the first thing we're going to have to do in order to complete the square is we're going to have to get the x squared completely by itself. And so what I'm going to do first is I'm going to put parentheses around these two, the first two terms, and I'm going to factor out a -1 because I want this to start out as an x squared. And I'm going to make what's inside here a perfect square. And so it's going to look something like this. I'll have y equals -1, and then I'm going to have x squared minus 4x, because -1 times x squared is -x squared, and -1 times -4 is +4x. And then I'm going to add 1 here. And so now I want to make this a perfect square. And so I'm going to have y equals -1, and in the parentheses I'm going to write this as x squared minus 4x. I'm going to leave a space in here to make it a perfect square. Then it's +1, and I'm going to leave a space outside of the parentheses as well. And so I want this to be a perfect square trinomial. I want to write it as x minus 2 squared. But in order to have a 2 here, that means this has to be a +4, because -2 squared is +4. But I really didn't add a 4 to the right side of the equation. I added a 4 times a -1. I added a 4 times a -1, which is -4. So over here, I'm going to add 4 to balance that out. I added a -4 here, and I'm going to add a +4 here. And so now if I finish this, I'll have y equals -1 times x minus 2 squared plus 1 plus 4 is +5. And so this equation now is in vertex form. And my vertex is going to be at the point 2, 5. The parabola is going to open down because the a value is negative. And I can go ahead and graph it from there. This would be the same thing as if I did it the other way. The other way we did this in class was to rewrite this in vertex form by doing something like this. You know, we have y equals -1 because this a value here is the same as the a value in vertex form. You know how it's a times x minus h squared plus k. And so the a is -1. And then in order to figure out what the h and the k are, I'm going to have to find the vertex here, which is -b over 2a. That's going to be -4 over 2 times -1, which is -2. Well, -4 over -2 is +2. And so it's going to be x minus 2 squared. But then to figure out what k is, I'm going to have to plug 2 into this equation. So 2 squared is 4, so that's -4. Plus 4 times 2 is +8, well that's 4. Plus 1 is +5. And so we really have two ways that we can rewrite this equation in vertex form. We can complete the square and go this way, or we can find the vertex and go this way. So today what we want to do is use the process of completing the square and write our equations in vertex form using the way on the left. Let's take a look at another type of problem here. It says find the vertex of this parabola by completing the square. And so probably shouldn't see this answer here just yet, but that's okay. We're going to keep it there. I'm going to complete the square here. The first thing I'm going to do is put parentheses around this. I'm going to factor out a -5. So it's y equals -5. And then I will have in the parentheses an x squared. -5 times a -3x gives me 15x. I'm actually going to do this now. I'm going to leave a space here. This is -7. I'm going to leave a space here. And so then what I want to do is write this as a perfect square. It's going to be y equals -5. I want to write this as x minus 3/2 squared. But in order for this to be 3/2, the inside of my parentheses here is going to be 3/2 squared, which is 9/4. But it's not really 9/4. It's 9/4 times -5. Well, negative 5 times 9 is negative 45. And so I'm going to add a positive 45 fourths on the outside because I'm doing everything on the right-hand side today. Yesterday, if I added 9 fourths on one side, I added 9 fourths on the other. Well, here I'm adding a negative 45 fourths on the inside, and so I'm going to add a positive 45 fourths on the outside. And so then I have a negative 7 over 1, but I want to put that over 4. And so this is negative 28 over 4. And so if that's 28, go negative 45 plus 28, that's going to be plus 17 fourths. And in vertex form, it looks like this. Y equals negative 5 times x minus 3 halves squared plus 17 over 4. And my vertex is at positive 3 halves and 17 fourths. So let's take a look at a situation like this. It says the following equation models the height of a snowball after being launched in the air. How high does the snowball get and how long does it take for it to reach this height? So the snowball is going to go up and come back down. The height of the snowball that we want to find is the maximum height, which is the vertex. Well, in order to find the vertex here, we could do negative b over 2a, or we could do what we're learning today, which is completing the square. I'm going to factor out a negative 16 here, and so it's going to be x squared, and then negative 16 times negative 5x gives me the 80x. I'm going to leave a space here. Then this is 25, and I'm going to leave another space here. So I want to write this as a perfect square trinomial, which is negative 16, and then this is going to be x minus half of 5 is 5 halves squared. But in order for this to be 5 halves, that means up here I'm going to have to add 25 fourths to both sides. I'm adding 25 fourths on the inside, and then I'm going to add, let me get my pen back here. So if I added 25 fourths on the inside, I have to multiply that times negative 16. Well, that's going to be negative 100. So I'm going to add a positive 100 on the outside. And so this is going to be plus 125. And so my vertex is the point negative, or is positive 2.5, and then 125, which means the ball is going to get 125 feet high in 2.5 seconds. And so, again, this is the x value here, and this is the y value here, the maximum height. So that's what our homework assignment is for today. And you can work on this, and we will see you tomorrow in class.